following on from the previous video, we got to this stage here where we were trying to project vector u onto vector v. In our case, our v is our unit vector, so it doesn't matter if this is 2 or if it's 3 or if it's 7 across. When you project u onto v, the final answer will be this vector here. It will be this vector here. So it doesn't matter if this is 7 or if it's 17. It really doesn't matter. When you project u onto this, the final answer will be this thing here. So let's try and illustrate that. So let's project u onto this unit vector here. So to project it, we will need to perform the dot product. So the dot product will be this times this, which will be 3, plus this times this, which will be 0. So the dot product will be 3. And then we need to extract the magnitude of v. Well, the magnitude of v is this thing here. The magnitude of v is 1. So that will be 1, and then you square it. So that will be 1 squared will be 1, and then times it with the vector v. In our case, it would be this. So it would be this thing here. So now if you get this times this times this, it will give you a vector of 3 across, 0 up. So a vector of 3 across, 0 up. So it will be this vector here. So the point is that when you have a vector, you can just, if you want to know the x component, you can just project u onto this unit vector here. When it's a unit vector, it's really easy to compute. So project it onto here. So the final answer would be this vector here. Okay. It's kind of easy because we're working with it's easy now because, well, if this is 3 across, 5 up, what's the point of projecting this onto the x? It's going to be 3. You can just see it here. But in the future, it won't be that way because let's say you're trying to pull a box up a ramp. This is your vector v, and then you're applying it. You're applying a force of F here, say. So you can, if you want to know, so now you have the ability to work with this axis here. So this is your x, this is your y. So you can project it onto here. So it's easy now because everything's we set it up so it's nice and easy. But in the future, our x and y axis will be, it won't be horizontal and vertical. It will be at an angle. So I hope you can see that. So now let's continue. Where was I? So now if you have a vector u, you can also project it in the y direction. So projecting onto a y direction, this vector here, we can choose it to be a unit vector where 0 across, 1 up. So this is our vector. This is our unit vector j hat. Okay, so we can now project this onto here. So our final answer should be this vector here. So let's put it to the test. So we are trying to project this vector onto this vector here, onto this unit vector. And remember, we deliberately chose the unit vector because it's easy to compute. So now perform the dot product. So this times this will be 3. This times this will be 5. This times this will be 0. This times this will be 5. So the dot product will be 5. The magnitude of v, the magnitude of v would be 1. Would be 1. The magnitude here is 1. So now this thing here will be 5. This thing here will be 1. And then the vector, well, our unit vector here is this. So now it's going to be this 5 times 0, 5 times 1. That will then give us this. So our final answer is this thing here. It's this vector here, 0 and 5 up. So now let's extend it to 3D. So in the future, you're going to have a weird vector like this. Let's say it's 2 across, 3 in the y direction, and then 4 up in the z direction. Let's just say it's here. So your vector is from here to here. So now if you want to know the x component, then you can just project the vector u onto well, if you want to know the x direction, then onto I hat. So don't forget I hat will be don't forget I hat will be the vector 1, 0, 0. You're working 3D. So now this thing here, once a unit vector, it's really easy to compute. So so if you want to know looking at this vector here, which is u hat, not u hat, it would be this half arrow here. So project this vector onto the x direction. So it's you computing this thing here. If you want to know, looking at this vector here, project it on. If you want to know how far it has gone in the y direction, so project the vector u onto j hat. So that will then tell you the y component of this vector. And if you want to know the z component, then project the vector u onto what's the last? Well, whatever, onto whatever's here. Okay, I can't remember.